Now I will talk about molar specific heat of a gas at constant volume Cv. Molar specific heat of a gas at constant volume Cv. It is defined as the amount of heat required to raise the temperature of 1 mole of the gas through 1 degree centigrade at constant volume. Now small Cv is specific heat of a gas for 1 gram at constant volume, and capital M is its molecular weight. Then molar specific heat at constant volume Cv equal to mCv. Capital Cv equal to capital M small cv. Now molar specific heat of a gas at constant pressure Cp, capital Cp, it will be written as capital Cp, molar specific heat of a gas at constant pressure. It is defined as the amount of heat required to raise the temperature of 1 mole. Mind it, 1 mole and 1 gram, both are different. If 1 mole is written, that will be capital Cp, and 1 gram is written, that will be small cp. In a similar way, if 1 mole is written, that will be small cv, and if 1 gram is written, that will be small cv. Then molar specific heat of a gas at constant pressure Cp, capital Cp. It is defined as the amount of heat required to raise the temperature of 1 mole of the gas through 1 degree centigrade at constant pressure. And it will be capital Cp equal to capital M into small cp. Now, relation between two specific heats of a gas. First relation is Cp minus Cv equal to R, where R is the ideal gas constant. Cp minus Cv equal to R upon J also. R is universal gas constant for 1 mole of a gas. Heat lost or gained by n moles of a gas equal to heat lost or gained by n moles of a gas equal to Q equal to NCP delta T at constant pressure. Q equal to NCV into delta T at constant volume, where N is the number of moles of gas. Now I will talk about heat engines. What is heat engine? It is a device which converts continuously heat energy into mechanical energy in a cyclic process. In heat engine, heat energy is converted to mechanical energy in a cyclic process. It essentially consists of a source of heat, a sink of heat, and a working substance. There are three elements: a source of heat, a sink of heat, and a working substance in heat engine. Efficiency of a heat engine. What is efficiency of a heat engine? It is the ratio of useful work done by the engine per cycle to the heat engine Q1, heat energy Q1 absorbed from the source per cycle, and it is denoted by neta. Neta equal to work output upon heat input. Work output means W, heat input means Q1. W can be written as Q1 minus Q2 upon Q1. Q2 is the heat rejected to the sink. Now I will talk about second law of thermodynamics. What is second law of thermodynamics? Firstly, Kelvin-Planck statement. Kelvin-Planck statement. What is Kelvin-Planck statement? It is impossible to construct an engine which will produce no effect other than extracting heat from a reservoir and performing an equivalent amount of work. It is impossible to construct an engine which will produce no effect other than extracting heat from a reservoir and performing an equivalent amount of work done. Secondly is Clausius statement. What is Clausius statement? It states that it is impossible for a self-acting machine. It is impossible for a self-acting machine unaided by an external energy. No transfer heat from a body to another at a high temperature. Now, reservoir process. Reservoir process. What is reversible process? A process which can be made to proceed in an reverse in the reverse direction by variations in its conditions so that any change occurring in any part of the direct process is exactly reversed in the corresponding part of the reverse process is called a reversible process. Once again, I'm repeating once again the statement. What is the statement? A process which can be made to proceed in the reverse direction by variations in its conditions so that any change occurring in any part of the direct process is exactly reversed in the corresponding part of the reverse process is called reversible process. Then what is irreversible process? Just opposite of reversible process. A process which cannot be made to proceed in the reverse direction is called an irreversible process. It is just opposite of reversible process. A process which cannot be made to proceed in the reverse direction is called an irreversible process. Now I will talk about Carnot's engine. What is Carnot's engine? It is an ideal heat engine which is based on Carnot's reversible cycle. Its working consists of four steps such as isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. There are four elements: isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. The efficiency of Carnot's engine is given by neta equal to 1 minus Q2 upon Q1, or it can be written as 1 minus T2 upon T1, where T1 and T2 are the temperatures of source and sink. T1 is the temperature of source and T2 is the temperature of sink. Carnot's theorem. I will talk about Carnot's theorem. What is Carnot's theorem? It states that no engine working between two given temperatures can have efficiency greater than that of the Carnot's engine working between the same two temperatures. I am repeating once again the statement. What is statement? No engine working between two given temperatures can have efficiency greater than that of the Carnot's engine working between the same two temperatures. And secondary statement is the efficiency of the Carnot's engine is independent of the nature of the working substance. It does not depend on the nature of the working substance. Now, refrigerator. What is refrigerator? What is refrigerator? It is a heat engine working in the reverse direction. It is a heat engine working in the reverse direction. Here, a working substance absorbs heat Q2 from the sink at temperature T2. Here, a working substance absorbs heat Q2 from the sink at temperature T2. An external agency does work W on the working substance. A larger amount of heat Q1 is rejected to the source at a higher temperature T2. Then Q1 equal to Q2 plus W. Coefficient of performance. What is coefficient of performance? It is defined as the ratio of the amount of heat Q2 removed per cycle from the contents of the refrigerator to the work done W by the external agency to remove it. I'm repeating once again. It is defined as the ratio to the amount of heat Q2 removed per cycle from the contents of the refrigerator to the work done W by the external agency to remove it. It will be denoted by beta. Beta equal to Q2 upon W and W equal to Q1 minus Q2, then it can be written as Q2 equal to Q2 upon Q1 minus Q2, and it can be also written as T2 upon T1 minus T2. If you like my video, please like and subscribe my channel. Thank you.